All right, here's a more intricate example of an antiderivative kind of question. So as you can see, they're giving you the derivative here, and they're also giving you a value of the original function. So this is sort of asking you, instead of necessarily finding a general antiderivative, they actually want you to find the function f of x that satisfies both of these conditions. So what this is going to help us do is actually figure out what that c that we talked about in the last video actually becomes. So first thing we need to do, of course, is find the antiderivative. So let's use our general antiderivative, reverse power rule to start off. And then the first thing, actually the very first thing you probably want to do is just simplify that equation. So let me just take a second and rewrite that, because we don't have a reverse product rule at the moment. We only have reverse power rule. So the only way to do a reverse power rule is if this is something like x to the n. So x to the 3/2 is actually what this function becomes when you simplify it. So then the antiderivative, the general antiderivative, is going to be x to the n plus 1 over n plus 1. So x to the 5/2 over 5/2 plus c. Clean that up a little bit. That's going to be 2/5 x to the 5/2 plus c. That's f of x. And they gave us the fact that f of 1 is actually 2. If f of 1 is 2, this becomes 2 equals 2/5 times 1 plus c. 2/5 times 1 plus c. So c has got to be, what's that, 8/5? If c is 8/5, we can put that right back into our antiderivative equation. So that's going to be 2/5 x to the 5/2 plus 8/2. And that is our actual function f of x that has a derivative of x, square root of x, and f of 1 equals 2. If we plug in 1 here, we will get 2. If we take the derivative of this, we will get x radical x, aka x to the 3/2. Same thing. Okay? Let's try this one. So this one gives us a little more information. Not only do we have the a derivative here, we also have two pieces of information about f. And then what you probably noticed right off the bat is they actually gave us a second derivative here. That's okay. Antiderivatives work no matter how many levels you want to move back up. So if the second derivative is 12x squared plus 6x minus 4, we'll just go piece by piece and find the first derivative. So the original first derivative is going to be, again, reverse power rule on, oopsies, let's try that again. There we go. Reverse power rule on 12x squared is going to be 12x to the 3rd over 3. So again, the 12 is just kind of coming along for the ride. X squared becomes x cubed over 3 using our general reverse power rule. And yeah, I know some of you are probably already simplifying it as you go, and that's great. I'm just trying to show all the pieces. Plus 6x squared over 2 minus, and be careful here, you kind of sometimes lose track of where you are in the process, and you see this and you're thinking in your head derivatives, and you might want to just say, oh, that's just 0. But remember, we're going backwards here. What did you start with to end up with negative 4? Well, you must have started with negative 4x, and then of course plus c. So this is the first derivative, unsimplified, of course. Let's simplify it. So that does become 4x cubed plus 3x squared minus 4x plus c. And now we look back at what other information they gave us. Unfortunately, neither of these pieces of information are anything about f prime. So I can't do anything with this yet. I'm going to have to double dip. I'm going to have to take another antiderivative and then end up hopefully with something that I can simplify. So f of x, if I follow the same patterns, 4x to the 4th over 4 plus 3x to the 3rd over 3 minus 4x to the 2nd over 2 plus, again, just like the antiderivative of 4 was 4x, the antiderivative of c is cx. But now what? We still need to add a constant, but I don't want to add c because I don't know that it's the same as the c from before. So what I usually do is I just add d. All right, you could do c1 and c2, like I said, I think in an earlier video, but sometimes it might be easier to just use a different letter so you don't get mixed up. Clean this up one step here. So this is going to be x to the 4th plus x cubed minus 2x squared plus cx plus d. And that's f of x. Our general antiderivative for f of x is all these pieces right here. And they gave us f of 0 is 4 and f of 1 is 1. We can use those to find c and d. In fact, f of 0 being 4 is kind of a dead giveaway for one of them. Hopefully you can realize that, recognize that all these terms go to 0, even the cx if x is 0. And so d has to be 4. So actually, if f of 0 is 4, then d must be 4. Plug in your zeros, you'll get d equals 4 almost right off the bat there. So now f of x is x to the fourth plus x to the third minus 2x squared plus cx plus 4. And then we use the last piece of information to figure out what c is. So f of 1 is 1. Let's do that last part. F of 1 is 1. So 1 has got to be 1 plus 1 minus 2 plus c plus 4. Right? If you plug in 1 in all these pieces, this is what you'll get. So we clean that up. That's cancels, minus 4. So it looks like c is negative 3. And if c is negative 3, I can put that right back here to finish off the problem, which I'll do right on this last step. So f of x equals x to the fourth plus x to the third minus 2x squared minus 3x, because c was negative 3, and then plus 4. If I plug in 0, I get 4. If I plug in 1, I get 1. And if I take the derivative 2 times, I get all the way back to 12x squared plus 6x minus 4. You can double check it yourself, but that should be good to go. All right, hopefully that helps with some of the more complicated ones. Again, if you have any questions, be sure and let me know, and I will see you guys later.